In 1977, humanity launched two small spacecraft into the void. No crew, no weapons, no way to call them back. Just instruments, a golden record, and a question we weren't sure we wanted answered. What is out there? Those spacecraft, Voyager 1 and Voyager 2, are still flying. Right now, as you watch this, they have traveled farther than any human-made object in history, over 23 billion kilometers from Earth. And what they found, what NASA's instruments detected at the very edge of our solar system and beyond, has left scientists with more questions than answers. Some of those answers are beautiful. Some of them are deeply, deeply unsettling. Tonight, we open a vault on what NASA found at the edge of everything we know. First, let's understand what we're talking about. Our solar system is not just the 8 planets orbiting the Sun. It extends far beyond that, into a vast region of space filled with comets, dwarf planets, and the Sun's invisible influence. Surrounding all of it is something called a heliosphere. Think of it as a giant bubble, created by the solar wind, a constant stream of charged particles pouring out from the Sun in every direction. This bubble is enormous. If Earth is 1 centimeter from the Sun on this scale, the edge of the heliosphere is nearly half a kilometer away. And that edge, that boundary, has a name, the heliopause. It is a line where the Sun's influence ends and true interstellar space begins. No human spacecraft had ever crossed it until 2012, when Voyager 1 did exactly that. It became the first human-made object to enter interstellar space. And what it found there surprised everyone. Scientists expected interstellar space to be quiet, a calm, dark void, cold and empty. They were wrong. As Voyager 1 crossed the heliopause, its instruments detected something unexpected. The plasma, the hot, charged gas of interstellar space, was denser than predicted, and stranger still, it was humming. In 2021, NASA scientists analyzing Voyager 1's data discovered a faint, persistent plasma wave oscillation, a kind of monotone hum in the interstellar medium. Not a signal from aliens, not a transmission, just the natural vibration of the plasma itself, stretched across light years of space. But the universe had always felt silent, dead. This hum, faint as it was, suggested something else. That interstellar space is not empty. It is alive with structure, with energy, with plasma that connects the stars. Then Voyager 2 crossed in 2018 and found something even more puzzling. The boundary of our heliosphere, the heliopause, was not smooth. It was uneven, dented, as if something outside was pressing in. Scientists believe this is the pressure of interstellar matter, the debris and gas from ancient stellar explosions, a graveyard of dead stars, pushing against a bubble that protects us. Our solar system is sailing through a sea of cosmic wreckage, and that sea has currents we're only beginning to understand. Here's where it gets truly terrifying. Zoom out from our heliosphere. Way out, our solar system sits inside something much larger, a structure astronomers call the local bubble. It's a vast cavity in the interstellar medium, roughly 1,000 light-years across, with almost no gas or dust inside it. We live in a bubble within a bubble, surrounded by emptiness. How did it get here? In 2022, a team of researchers published a landmark study. They traced the origin of the local bubble, and what they found was both elegant and terrifying. The local bubble was carved out by supernovae. Between 14 and 15 million years ago, a series of massive stars in our galactic neighborhood ran out of fuel and exploded. Over a dozen of them, maybe more. The shock waves from those explosions blasted away the surrounding gas and dust, hollowing out a cavity in the galaxy. And those shock waves are still expanding today. Right now, at about 6 kilometers per second. We are living inside the expanding remnant of a chain of stellar explosions that happened millions of years before our sun even formed. But there's more. The researchers found that as the shock waves expanded, they swept up material at the edges, compressing gas and dust into dense shells. And those shells, those compressed remnants of ancient supernovae, are exactly where young stars are being born today, including some of the stars in the Orion Nebula, one of the most famous stellar nurseries in the sky. The death of old stars, creating conditions for new ones. We owe our existence, at least in part, to ancient explosions we can still feel the ripples of today. In 2009, NASA launched a small spacecraft called IBEX, the Interstellar Boundary Explorer. Its mission? To map the boundary of our solar system by detecting energetic neutral atoms, particles that stream back from the heliopause. What IBEX found stopped scientists cold. Stretching across the sky, completely unexpected, was a ribbon, a narrow band of intensely energetic particles, curving across the entire sky like a cosmic scar. It was 2 to 3 times brighter than anything else IBEX detected. Nobody predicted it. Nobody could explain it. And over a decade later, we still don't fully understand what it is. The leading theory involved the interstellar magnetic field, the vast, galaxy-wide magnetic structure that threads through all of space. Scientists believe that particles from our solar wind, streaming outward, are being reflected or trapped by the interstellar magnetic field. And the ribbon is where those particles are bouncing back. It's essentially an imprint of our solar system's magnetic interaction with the galaxy. But there's something about this that deserves a moment of silence. Our solar system has a magnetic footprint, a signature, something that marks our presence in the galaxy. If there are other civilizations out there advanced enough, they might be able to detect it. They might already know we're here. Now for the part that keeps astronomers quietly concerned. Our solar system is not sitting still. We are orbiting the center of the Milky Way at roughly 230 kilometers per second. And as we travel, we pass through different regions of the galaxy. Some emptier, some denser, some filled with gas and dust and radiation from ancient explosions. For most of human history, we've been moving through the relative calm of the local bubble, but that is going to change. Astronomers have identified a dense interstellar cloud, known as the local ribbon of cold clouds, that our solar system is expected to encounter. When we enter a denser region of the interstellar medium, the heliosphere, the bubble protecting us from cosmic radiation, could be compressed. In extreme cases, scientists believe the heliosphere could be compressed enough that cosmic rays, high-energy particles from deep space, begin reaching the inner solar system, reaching Earth. Some researchers have even linked past encounters with dense interstellar clouds to extinction events in Earth's geological record. This is not an immediate threat. The timescales are thousands to millions of years. But here is the uncomfortable truth. The protective bubble we've always lived inside, the one that shields this entire solar system from the raw violence of the galaxy, is not guaranteed. It has changed before. It will change again. And we are only just beginning to understand how fragile it really is. A hum in the interstellar plasma, a dented boundary, a ribbon that shouldn't exist, ancient explosions still echoing through space, and a protective bubble that may not last forever. This is what NASA has found beyond our solar system. Not monsters, not alien signals. Something in some ways more humbling than either of those things. Evidence that we are not standing outside of the universe, observing it safely. We are inside it, moving through it, subject to it. And the universe has no obligation to be gentle. But here's what I keep coming back to. Against all of this, the scale, the violence, the indifference of the cosmos, 2 small spacecraft, built by human hands, launched from a pale blue dot, are still flying, still sending signals home, still exploring. Maybe that's the most terrifying thing of all. Not what's out there, but the fact that we refuse to stop looking. Thank you for opening the Cosmos Vault. If this made you feel small and somehow amazed at the same time, hit subscribe. That's exactly what this channel is for. Drop a comment. What do you think is the most terrifying thing about deep space? I'll see you in the next one.